Alright, so here we are with Unit 8, um, lesson number 8, and we just looked at concentration, so we're going to look at what happens when you change the temperature of a reaction at equilibrium. So obviously there's only two things you can do when you're changing the temperature. You either increase it or you decrease the temperature. Um, and that will cause it to shift either to the left or the right. And it's not that straightforward, like the add, opposite, remove, same, because it depends on what kind of reaction you have, whether you have an endo or exothermic reaction, which is what this is talking about here. So if you're looking at this reaction right here, and you read it from left to right, notice heat's on the right, so it is a product. That means that this is an exothermic reaction. If you're reading it from right to left, the reverse reaction then would be endothermic. So you have to be careful with that. Notice this one looks almost exactly the same, but instead of putting heat, we just use energy. But notice the energy is on the other side. That changes this around, because now if you read this from left to right, the energy is now on the reactant side. That means that it is absorbing it. That's endothermic, and the reverse reaction would then be exothermic. So you have to be extremely careful. Another thing that they can do is, if they left heat out, for example, let's say this was not here, and they said that delta H was, just as an example, negative 10 kilojoules. Well, that's telling you the same thing, that the heat is a product. So you'd have to be careful with that. In this case, delta H would be positive 10 kilojoules. So they don't have to give you heat or energy in the equation. Sometimes they will write it completely separate. If it's in the equation, if the heat's on the right side, that means the forward reaction is exo, reverse is endo. If the heat or energy is on the left side, that means the forward reaction is endo and the reverse is exo. If they don't give it to you here and they give it to you separately, you got to be careful. Because if they say to you, if they leave out the two terms, if they left these out, you have no way of knowing which is exo and endothermic because they didn't put it in the equation. But if they write it separately, you do. If it gives you this equation and it says delta H is negative 10 kilojoules, that means that the forward reaction is exothermic. In this one, this means the forward reaction is endothermic. So you, of course, have to be careful. Now, how do you determine what direction it shifts in? Well, here's the two things. When temperature is increased, it's going to shift towards the endothermic direction. When temperature is decreased, it's going to shift in the exothermic direction. So you have to be extremely careful. So let's look at the example that's at the bottom. Right away, you see heat's on the right side, just like we did here. So that means that the forward reaction is exothermic, and the reverse reaction is endothermic. So you have to be really careful. And the other rule applies. Whatever direction it shifts to goes up in concentration, and the direction it comes from goes down. So it says if we add heat, which is the same thing as increasing the temperature favors the endothermic reaction, which we know in this case is to the left, so it's going to shift to the left, which means that what will go down in concentration is the other side. The NO will decrease, and the H2O will decrease. If we add heat, what's going to go up in concentration? Well, that would be the other side. The NH3 will increase, and the oxygen will increase. Okay, so here's another one down here. Notice now the heat is on the left side. That means that this reaction is endo, and the reverse is exo. So you have to keep that in mind. If we remove heat, and you look up here, if temperature is decreased, that's removing heat, it shifts to the exothermic side. So removing heat will mean it will shift to the left, which means that these will go up in concentration, but these will decrease. Whatever side it shifts from, away from, always goes down in concentration. And the other side, the carbon dioxide and the water, will increase in concentration. And this is temperature.